Welcome to this video. In the previous video, we studied the state of matter. Let us now study the effect of temperature and pressure changes in this video. Friends, you must have seen ice melting in water and would have seen water changing into water vapor on heating. From these observations, we can say that water can exist in three states of matter: in solid, liquid, and gas. But have you ever thought about what happens inside matter when the state changes? What effect does the change of state have on the particles of matter? Let us try to find the answers to these questions in this video. Take 150 grams of ice cubes in a beaker and hang the thermometer in such a way that the bulb of the thermometer is touching the ice. Start heating the beaker on low heat flame and note down the temperature when the ice starts melting. When the entire ice turns into water, note down the temperature again. Note down the observation in the change from solid to liquid. Now, put the glass rod in the beaker and heat it by stirring till the water starts boiling. Keep an eye on the measurement of the thermometer until most of the water vapor is formed. Note down the observation in the change from the liquid state to gaseous state of water. Let us first discuss observations in the conversion from ice to water. First of all, we will see when and why ice changes to water. When we start heating ice, the kinetic energy of particles present in ice or solid increases as the temperature increases. As the kinetic energy increases, the particles vibrate more quickly. The energy supplied by heat overcomes the forces of attraction between the particles. The particles leave their fixed positions and start moving more freely. A situation comes when ice, solid, melts and becomes water, liquid. And do you know another interesting thing? The temperature at which a solid melts and becomes liquid is called its melting point. The melting point of a solid indicates the strength of the attraction force between its particles. The higher the melting point of the solid, the higher will be the attraction force between its particles. In this activity, you must have observed that the melting point of ice is 273.15 Kelvin. The process of conversion from solid state to liquid state is also called fusion. In the melting process, you must have noticed that after reaching the melting point, there is no change in temperature until all the ice has melted. The same happens despite providing heat to the beaker. So, where does thermal energy go in such a situation? Actually, this heat gets used up in changing the state by overcoming the forces of attraction between the particles. As this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the contents of the beaker and is known as the latent heat. The word latent means hidden. The amount of heat energy that is required to change 1 kg of a solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. So, particles in water at 0 degrees Celsius or 273 Kelvin have more energy as compared to particles in ice at the same temperature. Now, let us see what happens during the change from water to water vapor. When we supply heat energy to water, particles start moving even faster. At a certain temperature, a point is reached when the particles have enough energy to break free from the forces of attraction of each other. At this temperature, the liquid starts turning into gas. The temperature at which the liquid starts boiling at atmospheric pressure is called its boiling point. Boiling is a bulk phenomenon. Particles from the bulk of the liquid gain enough energy to change into the vapor state. For water, this temperature is 100 degrees Celsius or 373 Kelvin. And friends, do you know the amount of heat energy required to convert 1 kilogram of liquid into a gas at its boiling point at atmospheric pressure is called latent heat of vaporization. At 100 degrees Celsius, vapor particles have more energy than water particles at the same temperature. Can you explain why this happens? This is because vapor particles have absorbed excess heat in the form of latent heat of vaporization. By this activity, we can conclude that by changing the temperature, we can change matter from one state to another. Through this activity, we learned that when it is heated, they become solid to liquid and liquid to gas. But do all matters follow this rule? No. There are some substances such as camphor, ammonium chloride, naphthalene that convert directly from the solid state to gas and back to solid without being converted into a liquid state. Sublimation is the process of changing from solid state to gas, and direct change from gas to solid without changing into liquid is called deposition. Let us now see the effect of pressure change on the state of matter. Let us understand this by an activity. You can see that the gas has been filled in a cylinder, and this is how the piston is mounted on it. Now, what will happen if we increase the pressure on this piston? We have already learned that the difference in various states of matter is due to the difference in the distances between the constituent particles. Therefore, you will see that on increasing pressure and compression, the gas particles come closer. If we keep increasing the pressure, this gas will be converted into liquid. Have you heard of solid carbon dioxide, CO2? It is stored under high pressure. Solid CO2 gets converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. Thus, we can say that pressure and temperature determine the state of a substance, whether it will be solid, liquid, or gas. Is it necessary to always heat or change pressure to change the state of matter? Can a liquid change to vapor state without reaching the boiling point? Let us understand this with an example. When we dry clothes, the water in them slowly converts into vapor. How does this happen? What happens to water in such a situation? We know that particles of matter are always moving and are never at rest. At a given temperature, in any gas, liquid or solid, there are particles with different amounts of kinetic energy. In the case of liquids, a small fraction of particles at the surface having higher kinetic energy are able to break away from the forces of attraction of other particles and get converted into vapor. This phenomenon of change of a liquid into vapors at any temperature below its boiling point is called evaporation. Let us see what are the factors affecting evaporation. The rate of evaporation increases with the following: an increase of surface area. We know that evaporation is a surface phenomenon. If the surface area is increased, the rate of evaporation increases. For example, while putting clothes for drying up, we spread them out. An increase of temperature. With the increase of temperature, more number of particles get enough kinetic energy to go into the vapor state. A decrease in humidity. Humidity is the amount of water vapor present in air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. An increase in wind speed. With the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. Do you know another interesting thing about evaporation? Have you ever poured a few drops of acetone on your palm? You must have felt cold on the palm. It is also caused by evaporation. Acetone particles receive energy from your palm and its surroundings and evaporate, because of which you feel coldness on the palm. In this way, we can see that evaporation leads to coldness. Isn't it fun? Friends, in this video, we studied the effect of temperature and pressure changes on the state of matter.